going to cover section 3.7, angle side theorems. After studying this section, you'll be able to apply theorems relating the angle measures and side lengths of triangles. Now looking at our angle side triangle theorems, we have two theorems that relate our sides to our angles. So theorem 20 states if two sides of a triangle are congruent, the angles opposite the sides are congruent. So in an isosceles triangle, if we have our legs congruent, so let's say AB is congruent to AC, then our base angles, angle B and angle C, would be congruent. The converse of this theorem is also true. So if two angles of a triangle are congruent, then the sides opposite the angles are congruent. So if my base angles are congruent, so angle D is congruent to angle E, then my legs will be congruent. So side DF is congruent to EF. Now, because of these two theorems, I now have two ways to show that a triangle is isosceles. So if I show that at least two sides of a triangle are congruent, then the triangle is isosceles. If I had showed this in a proof, my reason would be definition of isosceles triangle, because the definition of an isosceles triangle states that at least two sides are congruent. The second way that I can prove that a triangle is isosceles is that I show that at least two angles of a triangle are congruent. Then the triangle would be isosceles. If I had this as a reason, I would have to state if two angles congruent, then triangle is isosceles. I cannot say definition of isosceles triangle because the definition of an isosceles triangle only relates to the sides and not the angles. Now, a common fact about triangle sides and angle measures, the largest angle measure is opposite the longest side, where the smallest angle measure is opposite the shortest side. This fact about sides and angles leads me to these two theorems. If two sides of a triangle are not congruent, then the angles opposite them are not congruent, and the larger angle is opposite the longer side. So I have a short form where if I have two side lengths, the one tick mark refers to my smaller side, the two tick marks refer to my bigger side, then I have the smaller angle here and the bigger angle here. My second theorem, if two angles of a triangle are not congruent, then the sides opposite them are not congruent, and the longer side is opposite the larger angle. So that's the converse of the above theorem. Now, the last fact about triangles is about equilateral and equiangular triangles. So I know the largest side is opposite the largest angle. Well, if I have all three congruent sides, that would tell me all three congruent angles. Therefore, if a triangle is equilateral, then the triangle will also be equiangular. Again, this only applies to triangles. This does not apply to other polygons. Now looking at our sample problems, I'm given that side AC is bigger than side AB. The measure of angle B plus the measure of angle C is less than 180. Measure of angle B is equal to 6x minus 45, and the measure of angle C is equal to 15 plus x. What are the restrictions on the value of x? Well, if I have side length AC bigger than side length AB, that would tell me that angle B is bigger than angle C. So 6x minus 45 should be bigger than 15 plus x. If I solve this, I would subtract x and add 45, so 5x is bigger than 60, so x needs to be bigger than 12. But also, I have that the measure of angle B plus the measure of angle C is less than 180. So 6x minus 45 plus 15 plus x should be less than 180. Combining my like terms, I'd have 7x minus 30 less than 180. Adding 30 would give me 7x less than 210. So x is less than 30. So the restrictions on x is that it should be between 12 and 30. Now looking at problem 3, I have the following givens, and I want to prove that triangle WTZ is isosceles. So this triangle here is isosceles. Remember, I can prove isosceles triangles two ways. I can show that they have at least two angles congruent, or they have at least two sides congruent. So let's look at our givens and see if we can prove that I have two angles congruent in my whole triangle, or two sides congruent. I'm given angle 3 is congruent to angle 4. That would tell me that angle WBX is congruent to angle ZAY, because if I have two angles that are sup to congruent angles, I can use my congruent supplements theorem. I have BX congruent to AY and BW congruent to AZ. So I have these two smaller triangles, triangle XBW and triangle YAZ congruent by side angle side, and angle W and angle Z are a part of these triangles. So I could state that angle W is congruent to angle Z by CPCTC, making my large triangle, triangle WTZ, isosceles because I have at least two angles congruent. So listing my statements and my reasons, I would have angle 3 is congruent to angle 4, and the fact that angle 3 and angle 4 were sup to angle WBX and angle YAZ, because if two angles form a straight angle, then they're sup. Now I can say that angle WBX and angle YAZ are congruent because my congruent supplements theorem. Then I have my next two givens of side BX congruent to AY and side BW congruent to AZ. Now my triangles were congruent, so triangle BWX is congruent to triangle AZY by side angle side. Then I use CPCTC to show that angle W is congruent to angle Z, and I can state that the triangle is isosceles because if a triangle has at least two congruent angles, then the triangle is isosceles. Looking at problem 4, I have the following givens, and I want to conclude that side DF, so this side, is congruent to side DG, this side. Now I have that angle E is congruent to angle H. These are the base angles of my large triangle, which would tell me that side DE is congruent to side DH, because if base angles are congruent, then sides are congruent. And then I have EF is congruent to GH. So now I have my two smaller triangles, triangle DEF congruent to triangle DHG by side angle side. And then I could say that DF is congruent to DG by CPCTC. So looking at this in my statements and reasons, I have angle E congruent to angle H. That would tell me that side DE is congruent to side DH, because if base angle is congruent, then my legs are congruent. Then I have my next given of EF congruent to GH. Then my triangles are congruent, so triangle DEF congruent to triangle DHG by side angle side. And then last is side DF congruent to DG by CPCTC. In today's lesson, we learned two new theorems about triangles. If two sides of a triangle are congruent, then the angles opposite are congruent. And if two angles of a triangle are congruent, then the sides opposite are congruent. Also, in a triangle, the largest side is opposite the largest angle, and the smallest side is opposite the smallest angle. That's a wrap on today's video. We'll see you in the next one.